All right. How's everyone doing? Can everyone hear me well? All right, great. Well, thank you for, I certainly appreciate this opportunity to talk to you about our experience with Tableau and working with it in the cloud. I'm Albert Wong. I work on Netflix's enterprise reporting platform. And today I'm going to go over the setup of the tools and the architecture that really enable us to do data viz and analysis. And with me today is Shri, who's part of the data engineering and analytics org. And he uses these tools on a daily basis to create data products to serve his payments partners. And later on, he'll be sharing some perspective in his experience of using these tools in tech. So with that, let's get started. We are a video streaming service, and today we're over 86 million members who stream 145 hours per day in aggregate. And we are a global company that is available in pretty much every country except for a few places that we can't do business, like China, for instance. Just a quick show of hands, who uses Netflix here? All right, great. So yesterday, we just released this new downloads feature. I don't know how many of you are aware of it, but before you guys fly back, you can download all the movies you want and play it on the plane. Anyway, back to the talk. So as you can imagine, all of that streaming that you guys are going to do later on produces a lot of data for us and quite a bit of opportunities for us to understand our customers and improve our service. So what is it that we're doing to ensure that we make the most use of our data? Well, first and foremost is this Netflix culture that we have. So we've published a culture deck that's available online if you do a quick search. You should be able to find it. It's about 100 pages, so I'm not going to go through it in depth too much. But the basic idea is that we really want to give our employees the freedom to be able to do what they need to do without a lot of boundaries, without a lot of process, and without a lot of controls. And we do that so that they can create impactful work and really be effective at what they do. I really recommend, if you haven't seen it, to take a look at it. I know it's a long read, but it does give you insight into how we operate, some of our philosophies and values. And as we go and progress through the slides today, and you discover and understand more about how we design our data architecture, you'll see elements of the design that reflect our culture, this freedom and responsibility culture. All right, great. So on the tech side of things, AWS has really allowed us to pivot from a DVD US only business and into the global streaming company that we are today. And on the data side of things, it has provided some services that are really key and core to our data strategy. So with that, let's take a look at our data platform. All right, so we have Netflix, you stream movies. All of that creates a bunch of events that get logged and then streamed into a place that, Amazon S3, which is where we store all that data. Additionally, we bring in operational data through a tool that we created called Aegis. All of that data also gets landed into S3. And on a daily basis, we get anywhere from about 700 billion events per day. And all of that is really low-level information. So what we do is we use systems like Hadoop and Spark to process that data and aggregate it into structures that are more suitable for databases, which we can put reporting on top of. Now, in terms of data viz, Tableau is our main tool that we use for visualizations. But we also use MicroStrategy D3 and something called Shiny in R for niche visualization use cases. Additionally, we provide tools like iPython notebooks and Jupyter and interfaces like the portal that allow you to do this additional data exploration work. And then finally, we have some internal data services that we built that really hold everything all together. So as you can see, we have a really rich ecosystem in the data platform. And what that really allows us to do is open up a bunch of data access patterns. And the idea is to create a platform that is very open because we want people to be free to do what they need to do with their data. All right, so let's focus on a few key technologies that are important to data viz. Well, so first and foremost is storage is very important to us. When you're collecting 700 billion events per day, we're starting to accumulate up to 60 petabytes of information in aggregate. And so Amazon S3 has been really good at being able to scale to our data volume needs. To me, it basically looks like an infinite hard drive. Whoops. And it's because of that scalability that we were able to make this strategic decision to build a central data warehouse. So all the data, like all the events data, all the operations data, even third-party data, we really put in a lot of effort to put all that into Amazon S3 and create a single source of truth. And then that allows us to, and that's really convenient for us because it allows us to ask a lot of questions and get results from a single source. All right, so let's talk about how we access that data. So up on the screen are three tools that we use to access S3 directly. Hive, Spark, and Presto are tools that provide SQL-like interfaces that really integrate well with reporting tools. And how it works is we have something called a Hive metastore, which basically tells you what all the files are in S3. So you can answer questions like, like for any given table, what are all the files associated and how are they partitioned? And and each of these tools connects to the Hive metastore. And so you can send Hive, Spark, and Presto queries. They will leverage the metastore to be able to understand what data to pull back from S3 and process that information and serve it back to you. All right. Oh, one more thing. So, you have all these tools that can access S3. What are some of the differences? Well, at a high level, what we've observed at our company is that Hive and Spark are really good for processing large jobs that deal with a lot of data. And so it might take a long time. Like we can have jobs that run for hours, but you can expect that they will process and return results successfully. On the other hand, Presto is really optimized for speed. And so you can send it a lot of queries, and Presto will just burn through them really quickly. But we do run into cases where Presto is not able to handle the amount of data volume that you're asking it to process. And in many cases, Hive and Spark are able to process that information. So you sort of have this trade-off between robustness versus speed among these tools. Now I mentioned that we aggregate data and we push it down into Teradata and Amazon Redshift. We use MPP databases because they are even quicker. They give you a lot of levers to pull in terms of distributing out how data is stored, ordering the data, indexing the data so that your queries can speed up. It really provides a lot of facilities to allow you to retrieve data quickly. One thing that it doesn't support is very large data volumes. So in the case of Presto, Hive, and Spark, you can access S3, which is at petabyte scale. But typically with Teradata and Redshift, we're loading data at terabyte scale. And so what we give up in data volume, we gain in speed. And the last thing is Druid. It's one of our newer data technologies. And as fast as Teradata and Redshift are, Druid is Druid is very quick, but very consistent in its speed. So in practice, one or two really poorly written queries in Teradata or Redshift can really slow down the system, whereas Druid is purposely designed to be able to do operations really quickly. And so Druid does this by, it's designed to limit some of the flexibility that you can do. So everything in Druid that you do is either an aggregation or a filtering operation. And so because of that, you can't do operations like find median counts or distinct counts. You also cannot join data, which is really useful in analysis when you're building up data sets and you're iterating on it and you're trying to bring in new data sets by joining in tables. Druid doesn't really provide that facility, but it does provide you very speedy queries and very consistently. And so we'll use Druid for really custom and polished data applications that require this consistent speed. Okay. All right. And to round out our list of key technologies in database, we have Tableau, which we use. I mentioned it's our main reporting tool. Up on the screen is a progression of screenshots that display what it takes to get from connecting to data to defining a data set to creating a visualization. And it's this really straightforward approach of connecting to data and creating a viz that really resonate with our visualization engineers. And it's the reason why we've seen such great adoption of it at our company. All right, so from the platform side of things, the tools that we provide, it's really important for us to be able to extend functionality. So when you run into roadblocks or things aren't working the way you exactly want them to work, it's important for us to be able to have the facilities or capabilities to be able to engineer solutions around limitations. And as an example, we use something called Tableau Server, which allows you to serve Tableau visualizations from a web interface. But in order to access those visualizations, you need to have a Tableau account created. And when we started using Tableau, we were manually adding people onto the system that needed access. And we knew if we were to use Tableau as an enterprise tool, that wouldn't scale out in the long term. And so we use something called Tableaus Rest Api, which allows us to do certain actions on the server, like add users through web calls. So what we did was we built a service around provisioning user accounts in Tableau on an as-needed basis. All right, so I mentioned that we use a lot of different data sources, and it's really nice having a tool that's able to connect to our diverse set of data sources. So for that really low-level granular set of data that we want to get to, we can connect Tableau directly to Hive, Spark, and Presto. For aggregated data, we can connect Redshift and Teradata in addition to Hive, Spark, and Presto. And unfortunately, Tableau doesn't support Druid, but 5 out of 6 is pretty good. For Druid, we use we use a web stack to communicate with Druid. And so we'll use things like D3, Node.js, JavaScript, React, and Redux. And we'll build data applications outside of Tableau to get to Druid. So earlier this year, we did run into some other scalability issues, particularly with the Hive, Spark, and Presto big data sources. And we found out what was happening was that queries run through the ODBC interface was experiencing a lot of issues with concurrency, and whereas like if you were run the same queries through a command line, you wouldn't experience those issues. So what we did was we ripped out ODBC from our architecture, and we built this internal library that could query from Hive, Spark, and Presto, fetch the data, and then by using Tableau's extract API, we are able to create something, an object called a Tableau data extract, which is basically just this highly compressed columnar data format specific to Tableau, but it's, it performs really well with the Tableau visualizations. And so yeah, I mean, after doing that, we've provided this like extremely flexible ecosystem on the visualization platform that allows us to freely connect to all the various data sources that we have. And as you can see, the majority of the data sources Tableau can connect to, and we're using Tableau for the majority of our visualizations. And then for special use cases like that need to access Druid, we're using our own homegrown web application tools, applications that we build from the ground up. All right, so that's how we've built, or set ourselves up to be able to work effectively with Netflix data. A lot of this was driven by culture, or this freedom and responsibility culture, to really make our platform open and accessible. The cloud provided a solid infrastructure for us to create all these tools and services on top of. And when you're working with 60 petabytes of data, a lot of the engineering challenges are scalability issues. And so we're constantly iterating on this data platform tech stack in order to address scalability. And then lastly, we're providing all these tools for our users to be able to work with data effectively. All right, so that sort of summarizes like the setup of what we have in place to support data viz and data analysis. My colleague Shri, he works with these tools on a daily basis to support the payments team, and he will come up and give you a little bit of his perspective on what it's like to work with these technologies. Thanks.
Hello, everyone. My name is Shrikant, and I work in the data engineering and analytics team at Netflix. And so Albert covered a lot of ground around the platform itself and how we set it up for scale. And so where I come in is how we leverage the platform for our own storage, processing, and to run our business, basically. And to make all the decisions that we need to make, optimizations that we want to do on a daily basis. Like, for example, I support global payments. So my role is all about how we're doing payments processing for Netflix members, and around the world, all the payment methods that we support, and whether things are running smoothly, as well as what kind of optimizations we can do with the data that we have in place. So we leverage a lot of the work that Albert and his team does. A little bit about my team itself. So my team has three core responsibilities, three core areas that we cover. The first one is the data engineering side. So we build a lot of pipelines using the tools and technologies like Pig, Hive, Spark, and a lot of Python. So it's all about building for scale and building for covering for a lot of the data needs that we have, the visualization needs that we have. And these are the tools that we use. And the second thing on the list is metrics. So do we have the right metrics in place to evaluate our business? And are we doing the right things for our business, and whether we are progressing in the right direction? And these are the metrics that we are constantly looking at as we are doing optimizations and we're changing variables in our business. The last one, of course, that's where we're all here for, is the visualization area. So we use Tableau and a lot of D3 and custom viz and MicroStrategy currently, so to do a lot of the visualization work in our team. So as the platform comes into play, we leverage all of these tools and technologies to do what we need to do. The types of I wanted to give you a perspective on the audience that we try to support. So we have two different kinds of audience. One of them is a more high-level, more executive type audience who care about trends and who care about the key metrics and who want to see whether the business is going in the right direction, how are the trends looking like, and they're focusing more at a high level, but at a more broader level. So that's one, and their needs are very different. And then on the other side, we have more power users. So these users are pretty much like they have more open-ended questions. They're evaluating A/B tests to see whether the test performance is good. As we are changing variables in our business, are the key metrics still doing good? Are there things that we are missing to see? So their questions are more open-ended. So they need much more data to be able to see all of these variables in action as things are changing. So their needs are different, and the tools that they use are very different as well. So those are the audience that we support currently. And the architecture that we put in place for that, for example, in our function, is Albert talked about S3 and how we use it as the fabric of our ecosystem. So everything starts there, and then we have processing tools like Spark and Pig to do a lot of the data processing and aggregation and summarization and validation of the data, whether it's in the right format, whether it has the right variables, the JSON payloads, and all of that happens on the processing side. Finally, once all of that's done, the aggregates are still stored back in Hive tables backed by S3 again. And the interesting thing that happens after that is we create a replica of that ag tables on Redshift and to use for visualization. So we power Tableau using our Redshift layer. This is not to say that we don't have Tableau workbooks connecting to Presto or Hive. It's just that most of our heavy-duty workloads happen in this kind of setup. And this is just like a general data flow of how things flow around in the system. So that's about the architecture. So I wanted to leave you guys, I'll also tell you about the products that we have in place and what these products look like, because everybody talks about data products, right? So the first one on the list is more of an exploratory kind, which you may be more familiar with. It's the interactive dashboards, right? As you think about these high-level audience, they're covering a lot of breadth. Are we doing the right things we need to do in Poland, Turkey, Japan? So they're checking these metrics on a regular basis, more like a lookup style queries. So they're seeing whether our trends are looking good, our key metrics are looking good, and they're very specific questions. So we've designed this experience to give them those answers really quickly, and through these exploratory and interactive dashboards. And as you can see, there are selections on the left to tweak things and change things and see how the metrics are looking, either by geo or by time or some other business variables that you want to look things through. The next one is an interesting one, and it's actually one of my favorite one, is Netflix is all about personalization. And everybody who's using Netflix knows about that, right? So how do we take that and take it to the next level to put it in terms of analytics use cases, right? So this is actually a Tableau dashboard, one Tableau dashboard that's serving multiple audience. And just a little bit background on this, right? So as you're operating in 190 countries, looking at different regions, looking at different geographic areas, you want to be able to know, very quickly where the action's happening. And it's much better if it's relevant to you, right? Like if you are, let's say like in this case, Pablo Escobar, he's on the hook to monitor LATAM region, and if there's any anomalous behavior happening in Colombia, for example. So he wants to see just that region in specific to him without worrying about everything that's happening around the world. So what we have is an anomaly detection algorithm running in the background that's doing all of the data processing and giving an output of all the key metrics that are changing and whether there's any anomalous behavior in a specific region with a specific metric and with some other specific variables. So with that, we're tailoring that output to these users and saying, this user cares about this region and these metrics, so let's show them just that. And they can always change it and go to the default view and see everything, but in their view, they're just seeing what they need to see, and it's very actionable when they see it. because they can quickly see whether they need to take action or not. So that's one view, and then the other user sees the other view, and if they care about more default view, then they can see everything. Like, for example, in my case, I'm not responsible for any one particular region, so that's why I get the default view in my email every day. So as I mentioned, this is one Tableau dashboard that's doing all the different views for the users. So just to quickly summarize on what's more helpful for us in these products use case is more of an iterative style development, right? Like, we want to be able to take a product and iterate very quickly on what's working for the users, what are the key things that you want to have, and what are the key metrics you want to have, what are the different selection filters. So being able to do that iteratively is very, very important for us, and that's something that we found very beneficial. The next thing is the storytelling aspect. Either you're telling your story in a table grid or a tree map or a line chart, simple line chart. You want to be able to see what tells the story in the best way possible and give it to the users. And then obviously connectors with such a rich ecosystem. You want to be able to connect to these data sources and go to where the data is, rather than having to do a lot of processing to get it to the place where it needs to be for Tableau to be able to access. So the connectors definitely help for us when you have so many different types of data sources. And the last one is being able to deploy. Just being able to quickly deploy and see what the user is seeing and work with the users, maybe send them a link, and then being able to do that very, very quickly is super helpful for us as well. So those are some of the things that on the dashboard side. Now, switching gears, if you think about the audience use case, those are all the things that are there for the most high-level users. Those are some of the examples of the products that we have. But the other side is the power users use case is actually very interesting, because in addition to all of the high-level context that they can get, they want to be able to drill down. They want to go much, much deeper into the data. And their questions are open-ended, so it's hard to build an experience that serves for all the questions that they could possibly get. So that's why we were looking for several different options to see how could we serve this better. And we've tried a couple different options. Just to let you guys know, is one of the options was just being able to have them connect to your data source directly. The problem with that is this is more business audience that want to be able to look at a lot of data, but not necessarily worry about the drivers that they're using. Or if you have like Presto driver or a Hive driver or a Redshift driver, and as these systems are evolving, the drivers are evolving. And we didn't want them to be worrying about like what driver they're using, whether they're using the right version. So that's not the place where we want it to be. The other option was more of a SQL queries, dynamic SQL option, where you could put in a SQL query and then run it, and then pull the data into the tool that you want, and then do your analysis that way. But the problem with that is the versions of SQL queries, and everybody is using, whether keeping track of who's using what queries, and whether they're using the right metrics, whether they have the same calculations that everyone has. Like, the standardization is very, very difficult, and it was getting out of hand as queries are just flying around and everybody's using different versions of it, and things were getting out of hand very quickly. So that's where we looked into, and this is our current architecture in production, actually. So the package data sources, everybody knows about Tableau data extracts, and so how many, just a quick show of hands, how many use Tableau on a daily basis today? So you're familiar with what I'm talking about. So Tableau does a lot of data extracts out of the box for a lot of the reporting and data sources. But what's interesting is, as we are taking the data from the data store and publishing it to the Tableau server, we're actually adding a lot of the metadata. And we're saying, okay, take this field and calculate this metric out of this, and take this into consideration, and so that the users don't have to do that again and again and again on their side. And we're also categorizing, saying that here's the geographic dimensions that you care about. Here's the hierarchical dimension that you care about. If you want to go from region to sub-region to country, we are creating those hierarchies as part of that metadata and pushing it along with the data source, so they don't have to worry about and do this again and again, over and over again. And as the data extract lands, as the data source, the package data source lands on the Tableau server, all they have to worry about is connecting to the Tableau server. So they don't need to worry about connecting to Hive or Presto or Redshift or any of these other sources. They just need to be able to see this package data source and just do their analysis rather than worrying about are they using the right metric or the calc, whether it's aged or not, and things like that. So this is what the user view looks like when they connect to one of these cubes, when connect to one of these package data sources. Onto your left, you're seeing they connected to a Tableau data source, but they're seeing geographic dimensions like hierarchies, calculated fields, whether percentage makes sense, or raw counts make sense, or a distribution makes sense. So we are doing a lot of that work as part of the metadata, and so that the users can readily leverage that and start using it. So that's been super, super helpful for us, and it's one of our, I think it's one of our success stories because we're cutting down on a lot of the duplication of work, SQL queries, drivers, not worrying about all the drivers and all of that. So that's been super helpful. And here are the key things that I wanted to highlight with this option if you're thinking of going this route. One is having everyone has the same context so that no user is using the metric in a different way or have the calculation wrong or things like that. So it's reusable, so no one's reinventing the wheel again and again and again. The other interesting byproduct of that is because you're putting these data sources on the Tableau server and folks are connecting to them, you can see who's connecting to what and what dashboards they have connected to what data sources, what metrics they're using. This is super helpful if you're doing any kind of maintenance work because we want to be able to change these, keep these live. You want to be able to change the metrics as business changes, add some new things, take away some existing ones that are not used. So you want to maintain these. And as you're doing that, you want to be able to see who's impacted. And the old way, you can really not tell until you change and somebody screams saying that things are broken, can you take a look? So rather than worrying about who's connected to what and the maintenance issues around it, we're just worrying about the engineering side of things. How do we engineer this for scale? How much data can we put here? And how do we scale this for more users? Rather than worrying about the SQL queries and the drivers and the versioning of it and all of that. So as you're making changes to these data sources, you can see who's impacted. You can communicate to those users, work with them, maybe change things, help them change or switch to the new versions and things like that. So that's been super helpful. And we pushed like few changes already, and that's talking from the experience, actually. So this brings up, you might have a question of how much can I do this, right? Like how big can these extracts be? How much data can I fit into this? So we've tested up to 100 million records with these extracts option, and that may seem like a small number compared to the overall context of things. But if you think about the context of where we use it and how we use it, these are very wide tables. So this is about like 100, 120, 130 fields wide tables. And a lot of it is dimensions. And those dimensions have very varying cardinality. So some dimensions have 3 unique values. Some other dimensions have tens of thousands of unique values. So you're able to serve like different kinds of use cases with it. But I just wanted to provide that context as you're thinking about this route. You can really scale it up if you have like a smaller data sets, but because our use case was going more wide and being able to provide all kinds of answers to all the different questions, we chose to put as much dimensions and metrics as possible. And just the scale itself, if you think about it, that's about 90 gigs of uncompressed data. And after Tableau does its compression, which is the columnar compression, and it's taking all those unique values and compressing that, it becomes about 6 gigabytes of compressed data. The other small context I wanted to provide is this is more for an operational use case. As you're doing A/B tests, as you're changing variables in the business, you want to be able to see how last month's progressing. So this is not for like taking years and years of data. Of course, if the data set is small, then it makes sense. You can go very far back. But in our case, we use it more for operational, and our other data products more for looking long-term and how things are going. There's a couple of other things that I wanted to leave you guys as we are moving away from this area. One thing is, you may have seen this option in other BI tools. Like Cubes is something it's not very new. A lot of other products have this option, but the difference is, like previously, if you had to do cubes, it's more like a sandbox environment where you have like few chart types, you have your metrics and dimensions, and you have your drag and drop. But what we're doing here is we're taking a Tableau editor, which is like a full, rich editor with tons of different features, and bringing the data there, and having the users use the Tableau editor on top of this data, which is already built in with so many different features. So that's been super, super helpful, because you're not having the user go to a sandbox style environment where there are limited things that they could do. They could create their own table calculations. They could create their own LOD calculations that Tableau gives. So I think that's the success metric there. And then the other thing is, as a team, we don't want to be the bottleneck as well, as things are moving fast. And we want to empower everyone to be able to do these things, make their decisions fast as they're working in different regions, rather than being dependent on us for answering these questions for them, or to be able to create dashboards and reports for them. So by doing this, we're taking ourselves out of the equation a little bit and worrying about the engineering side of things, than worrying whether the business is getting those answers really quickly. So I just wanted to leave you guys with that context as well on this option. A couple of different, as we are talking about scale, and Albert talked about Druid. I love Druid. Druid's great, but it has its own challenges, because it can only, you need a custom wrapper on top of Druid to be able to talk to the REST API and get the results back. But let's say you want to have a Sankey or a dendrogram or an interesting other chart type that you want to use for your data set, and you want to power that with Druid because it's fast. And let's say you want to have Tableau on the side, like have Tableau charts also on the side. So one thing that we're experimenting with is with the JS API, how much Tableau embeds can we do and where it makes sense. Obviously, it has to be tasteful and it has to make sense. But something that we're experimenting is dynamic annotations, because annotations feature is kind of okay in Tableau, because you cannot really add annotations from the server. So we're playing to see if we can put a custom wrapper on top of Tableau and have those annotations appear dynamically on the Tableau dashboards. So something for you guys to think about. The other thing is XML hacking. It speaks more to the culture than anything else. When you have tools and they don't work like the way you want them to work exactly at a few places, then a lot of times you just open it up and then see what exactly is happening in the background and how things are being set up, and then start to tweak things like the way you want them to. So in this case, the dashboard that you're seeing on the right, if you open it in an XML editor, that's what it looks like. And I figured there would be a lot of devs in the room that would appreciate this. Maybe? No? So being able to see what's happening in the background, how Tableau is setting things up, and tweak things like the way you want them to. Like, for example, switching data sources is a pain a lot of times, like because things break, calculations break, like views break, and the colors get changed, color palettes get switched around. So if you want to be able to do that in the background, like you could go here, like I've gone here to switch color palettes out, to switch data connections out, and with data sources, or even Tableau workbooks. So that's something I wanted to like also highlight, and how we operate in general. So at this point, that was all about the context and how we use the tools and the products that we build. But I wanted to leave you guys with some takeaways, some concrete takeaways on if you're thinking about scale and worrying about large data sets and how to use Tableau or any other tool. Some of these are general. Some takeaways to keep in mind as you're going this route. So the first one is more of a dev tip. So as you're doing a lot of the iterative stuff development, and you have these giant data sets in your data store, rather than streaming all of that data at dev time, create smaller local extracts and work off of that and iterate fast. And or if your database supports it, views with a limit condition and have maybe like 10 days worth of data, and then create your viz. And then once you publish to your server, remove the limit condition from the view on the data side, and that just streams entire data set next time it runs. So more of a dev tip as you're doing development. This is more of an observation that we made. And you may have run into this and seen this as well, but for dashboards itself, we felt like extracts are the best option, than going the live route. The reason for that is because as you're creating these Viz and Tableau is drawing these visualizations, and you have these Tableau like data calculations or table calculations, it's doing all of that in the background. So if you're using a live connection, it has to stream all that data back and do those connections and draw the Viz. Versus if you're using extracts, so when you're updating that extract itself, Tableau is pre-creating and setting things up for you and doing all of that calculations beforehand, and it's pre-done. So when you load up the Viz, all it has to do is take the memory mapped file and load it up, rather than doing all these calculations on the fly. And so that would speed up the Viz a lot. And this is especially true for dashboards, because you don't want them having those spinner wheels and waiting for the views to load, and have things be more snappy. So this is also a very recent observation, actually, as we are working with Redshift more, and as we're working with Redshift, we've seen this happen, is your jobs run fine, and then Saturday or maybe Tuesday happens, and then suddenly everything's delayed. And you see this constantly happening for every Tuesday or every Saturday. So what happened in our case was there were system jobs that were running that were getting kicked off on these days, and they were doing a lot of the maintenance work at the same time as our works were running. And this affects you if the jobs are crunching through a lot of data and streaming a lot of data, versus small jobs get in, get out fast. So there was conflict of resources for a while, and all of our jobs used to get delayed. So once we've gone to the bottom and figured that there were these system jobs that were running, we're working with the Redshift team to figure out how do we move them and how do we work with them so that we are not impacted or the business is not impacted. So something to keep in mind, if you see that behavior as on a periodic basis, then something to look into. The fourth one is if you do decide to go the live route, we've tested some live connectivity with Redshift SSD and Redshift Vanilla Redshift as well. And one of the things that we've run into quite often is the concurrency side, where if you think about a Tableau dashboard, it has multiple views and multiple selections and filters. So it's issuing multiple queries back to the data store and to power that Viz and to draw that Viz. So all of those queries end up on your data store, and if your data store has any kind of concurrency limitations, all of those get throttled and are waiting to execute. And this is especially true in Tableau, because Tableau issues all of these queries as you're loading up the Viz, and it's issuing all of these queries to the store. And a lot of these, you would see the lag time on your data Viz load times, on the data Viz load time. So if you're running into that, then checking the concurrency limitations of your database, the driver itself, you may be able to tweak some of the concurrent, like how many concurrent connections can I have? Can I bump it up to 4 or 5 or 6 maybe? And obviously you may have to see like what the database supports, but you can tweak that in the TDC file, which is a Tableau data connectivity file. And the other thing you could look into is the query fusion side of things. As Tableau is issuing those queries, it's getting as the product's getting intelligent, it's clubbing or it's combining a lot of these queries so that it's issuing fewer queries rather than every object as a query. So as Tableau is getting better at it, but you may still see a lot of queries going back to the data store and getting throttled. So check to see if Tableau is doing query fusion effectively. Something to keep in mind. This one may sound like a cliche, but I feel like it's very, very important. This is the last one that I wanted to leave you guys with. This is especially true if you're working with giant data sets, and you want to see how the user performance would look like on these giant data sets. So actually build the Viz like the user would do it. Like for example, in our case, how the user would use the extract. Rather than doing, okay, I'd do a quick filter and then maybe a chart and then assume that it works okay with streaming that data set. But the user may use it entirely differently. He or she may have like tons of, like 4 or 5 different charts with year-over-year analysis, maybe some table calcs with some quick filters. So the Viz might look entirely different when the user actually starts to use it. So test with the user in mind, and so you're not surprised when the users actually start to hit that large data sets. So that's the last one I wanted to leave you guys with. And at this point, so Albert talked about the download feature. This one's not for download yet. So, and I don't know how much time we have. We have about 15 minutes. So we do have time for questions, and we'll also be at the Netflix booth right after this talk. So in case anyone wants to stop by, and we'd love to meet as many of you guys and hear your stories as well.